from the team with report graphs-based method for detecting cyber threats in a real-time systems.
Yes.
Sergey, please.
Can you see my screen?
Sergey, are you ready?
Okay.
Okay.
Uh, a graph-based method for detecting cyber threats in real-time system. Dear colleagues, today I will present a research dedicated to a new approach for dedicated cyber threats using graph models. Our work aims to create an effective system for a real-time threat detection and mitigation. Introduction. In today's world, the integration of information system into our life has become integral, and life without this system is immeasurable. Cyber attacks on this system can affect many people and cause both material and moral harm. Unauthorized access to network and system can significantly damage us as a whole, while the chaotic increase in the number of users, data volume, and its distribution can lead to fears and security breaches. Our research focuses on developing method for detecting cyber threats in an information system and assigns the allocation of threats to develop countermeasures. The main goal is to preserve the function, properties, and resources of a network for its owners. Um, Overview of uh, existing methods. Existing methods for dedicated cyber attacks on communication channels of information system includes various approaches to identification, usually or malicious activity within the networks. This method focus on detection anomalies, attacks, intrusions, or uh, vulnerabilities. Among the main approaches are intrusion detection system, the monitoring traffic to identify usually patterns of anomalies, a signature-based method for detecting known attacks, machine learning algorithms for analyzing and detecting anomalies, or checking invoice logs for detection challenges or unauthorized access, intelligent system for recognize usually of malicious behavior in the network. Proposed method. Our method includes key several key models for intelligent cyber threats analysis, traffic collection and statistic generation models, training model, cyber threat detection model, alerting model. The method is planned to be monitored separate for each application layer protocol. For example, for manager FTP traffic, only data released to the FTP server will be used. Similarly, database data will be used for monitoring SQL queries. Uh, the detection and alert graph for cyber attacks. Our method used to types of graphs, network graph for cyber threat detection, and a set of vertices uh, representing various aspects of cybersecurity. L set of detracted edges reflecting the international ships between vertices. W weight function indicating the importance of priority of each edge. And cyber alert graph, MLR, a set of alerts, a set of degraded edges, connective vertices in the graph, and a function defining relations between alerts and vertices in the graph. This graph allows the cybersecurity system to track and analyze potential routes of cyber attacks responding to the base and the time and type of vulnerabilities. Uh, Selection of countermeasures. After detecting a cyber attack, it is crucial to develop an approach to select appropriate defense measures. For this, we use a comprehensive index L for the escalation countries formula, and where A1 and A2 weight coefficient for the impact for countermeasures, identification of invoice or identification of invoice of the countermeasure, C identifier of cost associated with implementation of countermeasures, and normalization coefficient. In addition, we use the stability index to assess the vulnerability of nodes in the system. This formula, where WV is a vulnerability rating of a node based on its characteristics, and WVU is a vulnerability rating of a node during our operation system. Experimental result. The experimental conducted in a private cloud environment confirms the effectiveness of the developed method. This is special important as the extra goal may be to compromise it, virtual machines or other price resources. The chart shows the comprehensive index for selecting Gaussian L, reflecting the magnitude of negative impact. The values 1, 2, 3, and over n represent elements. It also shows the cost required for implementing countermeasures in terms of resource and operation complexity. The higher the score, the higher the cost. These indicators together representing to comprehensive countermeasures selection index L. Note that countermeasures with harm compromising index compressed to more serious measures that can potentially alter nearly the entire infrastructure of a virtual cloud environment. System architecture. Our proposed system for detecting cyber threats in real time consists of several integration models. traffic collection and statistic generation model. This model intercepts all traffic passing through the network node, extracts special features, and calculates statistic over defined period. A training model. This model creates a cyber threat detection graph, collecting data on no vulnerability in the intelligence information network and connection information. It allows for prediction possible cyber threats and attacks by determining dependencies between detect event. Cyber threat detection model. A cyber threat detection model utilize the alert graph of cyber attacks, which consists of vertices representing vulnerabilities and disease exploitation. This all is a model to compete the propagation path of cyber attack within the network. Each features of this model include real-time analysis of network traffic, correlation of detection events with known vulnerabilities, identification of potential attack paths, alerting and consumer selection. The threat alerts model select countermeasures for the relevant trend detection scenarios. To cite on the required type and level of protection, we use a specialized management algorithm that handle the dynamic changes in intelligence information management objectives when vulnerabilities are detected or certain nodes are identification as susceptible entertainment. Countermeasures can be taken to limit the attacks and opportunities. The aim of countermeasures is to protect network nodes for being compromised. Security metrics and risk assessment. To maintain system stability, we until several security identification for performing scientific tasks. This identification help assess to risk level in the context of a specific network configuration and threat status. Key metrics includes global variable indicator, denotes the probability of priori risk and initial stage of attacks based on data from the National Vulnerability Database. Function Stability Index serves as a quantitative measure of the stability of each individual node within the system. This matrix allows for a more nuanced understanding of network security and help prioritize countermeasures based on the most critical vulnerabilities and potential impacts. Dynamic adaptation for countermeasures. To improve the countermeasure selection algorithm, we implemented several enhancements. Utilization of data from the cyber attack alert graph and database for the node threats to more effectively restrict the exertion of attacks. Dynamic engagement of countermeasures based in the current state of the network and change in the threat levels. Continuous continuous network monitoring and application of machine learning technologies to predict potential attacks. Mm, Contextual consideration in a countermeasure selection. Once selection countermeasures, it's important to consider the context of each node's use. Critical nodes that provide an essential service receive priority protection, even if with increased cost. The interrelations between nodes and taken into account to identification key nodes whose protection has the most significant impact on our network security. This approach allows for optimal resource allocation for countermeasures, ensuring that the most critical assets are protected visual and sounding branding less critical parts of the network. Experimental result and validation. Our
In 2 minutes,
experiment,
please. Sergey, in 2 minutes, please.
uh, uh, our experiment content in the private cloud environment confirmed the effectiveness of the development method. The results show that our approach transforms existing method in several key areas. Detection rate. Our method demonstrates a higher accuracy in identification potential threats. Follow position rate. We observed a significant reduction on false alarms compared to the additional approach. Response time. The gray-based approach allowed for a faster identification and mitigation of threats. Uh, Conclusion and future works. In conclusion, our graphs-based method for detective cyber threats in a real-time system offers several significant advantages. Comprehensive threat modeling. By using network and LD graphs, we can model and understand the complex interaction between vulnerabilities, attack methods, and protecting measures. Dynamic adaptation. Our system can adjust to the giant threat languages and network configuration in real time. Contextual environments. By consistent the important and relation between nodes, we can prioritize protection for critical assets. Our research contributed to the ongoing efforts to secure in critical complex and in critical information system, providing a robust fundamentals for future developments in cybersecurity. Okay, thank you.
Thank you, Sergey.